Ever felt like you're just drowning in spreadsheets? Or, trying to wrap your head around how some huge software system actually holds all its data together?
Yeah, it can feel super complex.
Okay, let's unpack this then, because today we're diving into something foundational that really helps simplify all that, the entity relationship model, usually called the ER model.
Think of it like a secret decoder ring for figuring out how information systems are actually put together.
Exactly. And what's really interesting, I think, is that even though it sounds technical, it's actually a brilliant shortcut. It helps you understand pretty much any system you interact with.
Right. So whether you're just curious about software or maybe you need to prep for a tech discussion or, you just want to understand a really key concept in our digital lives,
Yeah,
the ER model is surprisingly useful.
totally. And to guide us through this deep dive, we've looked at some great sources on the originator, Dr. Peter Chen.
Uh-huh.
We've got his university homepage, a bio, his Wikipedia page, and, crucially, his really famous 1976 paper.
Ah, yes. The entity relationship model toward a unified view of data. That's the one.
That's the one.
Mm.
So our mission today, it's really to get into the core ideas of this ER model.
And figure out why it's still so influential, right?
Yeah.
Across so many different bits of technology, even today.
Precisely. So let's start with the man himself, Dr. Peter Chen.
Right.
He's a Taiwanese-American computer scientist, also an applied mathematician,
Uh-huh.
and his career, well, it spanned decades.
Yeah, really impressive list of places he's taught. LSU, Carnegie Mellon, MIT, UCLA,
Mm-hmm.
even Harvard, where he studied.
But the key thing, the reason we're talking about him, is that he is the originator of the entity relationship model.
Absolutely. It wasn't just, a small tweak. This was his major contribution. And it fundamentally changed how people thought about data and database design.
And this big shift really happened with that paper in 1976. You have to picture the time, right? Early days for databases.
Oh, yeah. People were still figuring out the best ways to structure data, how to visualize it. It was kind of messy. No real standards yet.
A bit like the Wild West of data structuring.
Something like that.
Yeah.
And into that environment comes this landmark paper, published in ACM Transactions on Database Systems. That's a top journal.
And it wasn't just another paper. It became like one of the most cited papers ever in computer software.
The impact was huge. It really did become the bedrock for database design. And the citation numbers, even decades later, are just incredible.
I saw that, like, January 2005, nearly 30 years later, it was still the fourth most downloaded paper from the ACM Digital Library.
Wow.
That's staying power, isn't it?
It really is. And, the core problem he was tackling, it was this lack of a clear, unified way to just think about the data conceptually before you even got into the weeds of specific database systems.
You wanted a map, basically, a high-level blueprint.
Exactly.
Okay, so let's break down this ER model. What are the fundamental pieces, the concepts that made it such a breakthrough?
Right. So at its heart, it's actually pretty simple. It breaks data down into a few key things. First, you've got entities.
Entities, okay.
These are basically the real-world things or concepts you want to keep track of. Think like a customer, or maybe an order, or a product. The main nouns, you could say.
Got it. The things. So what else?
Well, that each entity has attributes. These are the properties or characteristics of that entity.
Ah, the details.
Exactly. So for a customer entity, attributes might be their name, address, maybe an email. For an order, it could be the order date or the total price, like the adjectives describing the noun.
Okay, entities are the things, attributes are their details. How do they connect?
That's where relationships come in. Relationships show how entities are linked or associated with each other,
Like the verbs.
pretty much. So you might say a customer places an order. That word places represents the relationship between the customer entity and the order entity.
Right, linking them together. And I think I saw something about cardinality and participation. They refine these relationships.
Yes, exactly. Those add important detail. Cardinality tells you about the numbers in the relationship. Is it one-to-one? Like maybe one employee has one company car.
Okay.
Or one-to-many. One customer can place many orders. Or even many-to-many, like many students can enroll in many courses.
Uh-huh. And participation.
Participation defines if an entity has to be involved in a relationship. Is it mandatory or optional?
Okay. Example.
So maybe every order must have a customer linked to it. That's mandatory participation for the order. But a customer might exist in your system before they place any orders, right? So their participation in the places relationship could be optional.
Ah, I see. So those details add a lot of precision.
They really do. And what's amazing is these core ideas, entity, attribute, relationship, cardinality, participation, they're still taught everywhere. Foundational stuff in computer science and information systems programs globally.
It's like a universal language for data modeling,
Mm.
but wasn't a big part of the aha moment, the visual aspect, the ER diagram.
Oh, absolutely crucial. Chen didn't just give us the words. He gave us the picture, the ER diagram. Suddenly, you had this standardized way to draw your data structure. Rectangles for entities, ovals for attributes, diamonds for relationships, lines connecting them.
So engineers finally had a visual blueprint.
Yes. And that was revolutionary.
Wow.
Because it wasn't just for the database gurus anymore.
Okay.
Business analysts, managers, other stakeholders.
Yeah.
They could look at this diagram and actually understand the proposed data structure. They could participate in the design process.
I had a much more collaborative.
Hugely. And another key point, the ER model, the diagram. It was independent of any specific database technology, meaning you could design your data conceptually first using this model before you decided if you were going to use a relational database or a network one or something else. It was a planning tool.
So you'd map it out with ER and then figure out the implementation.
Precisely. Became the standard way to plan. And because of that clarity and utility,
It just took off.
it really did. Widespread adoption. Pretty much every industry you can think of started using it. Banking, healthcare, government, tech. It became the default blueprint for database design.
Wow. And it got formalized too, didn't it? It became like an official standard.
You're right. It was actually adopted as the meta model for the ANSI standard for something called the Information Resource Directory System, or IRDS.
Okay, sounds official.
Yeah, and surveys back then, looking at Fortune 500 companies, they consistently rank the ER approach as the top method for database design and one of the top methods for systems development overall.
So industry basically said, yep, this is the way.
Pretty much cemented its status.
And the impact didn't just stop at designing the databases themselves, right? It sounds like it laid the groundwork for other tech, too.
Oh, absolutely. It was foundational for what we call CASE tools, computer-aided software engineering.
CASE tools. Like what?
Think of software like Irwin from Computer Associates or Oracle's Designer 2000, Sidebase's Power Designer. These tools basically automated drawing ER diagrams, generating the database code, creating documentation.
So building on the model to make development faster.
Exactly. A big leap from doing it all by hand. Even general drawing tools, like Microsoft Visio, you can see the influence of ER diagramming conventions in there.
Makes sense. So it shaped the tools developers actually use.
And it goes further. Modern ways of working with data, like Microsoft's ADO.NET Entity Framework, still built on ER principles.
Still relevant today, then.
Definitely. And it also influenced the thinking behind object-oriented analysis and design. You know how you model software systems using objects and classes. And UML, the Unified Modeling Language, there's a conceptual lineage there too.
Interesting connection to object-oriented thinking.
And here's maybe a surprising one. Hypertext, the very concept behind the World Wide Web.
Really? How so?
Well, think about it. Entities connected by relationships. Dr. Chen was actually involved with some of the World Wide Web Consortium's XML working groups later on. The core idea of linking information nodes. It has conceptual roots in ER thinking.
That's a pretty deep connection. It's really clear his work was hugely valued.
Oh, massively. They even established awards in his name. There's the Peter P-Shan Award, started in 2008, for major contributions to conceptual modeling.
Right.
And more recently, in 2015, the Peter Chen Big Data Young Researcher Award, to encourage new work in that area.
Nice. And he received quite a few major awards himself, I gather.
Absolutely. Really prestigious ones, like the IE Harry Good Award. Previous winners included inventors of the first computers, core memory, foundational stuff.
Wow. Heavy hitters.
And the ACME Air Alan Newell Award. Again, previous winners there include Nobel laureates, National Medal of Science winners. So he's recognized at the absolute highest levels.
That says a lot. And beyond those huge awards.
Lots of recognition from professional bodies. He was made a fellow of the IEE, the ACM, the ACcolades, that's the American Association for the Advancement of Science, and the ER Institute.
So top honors from his peers?
Yep. Plus, listed in Who's Who in America and the world for over 20 years. He was even called a software pioneer at a conference in Germany.
A pioneer. Seems fitting.
And maybe most fundamentally, his work is just in the curriculum. It's in the textbooks. Part of the official ACME recommended curriculum for computer science and related fields. You basically can't study databases without learning the ER model.
It really sounds like Peter Chen's ER model wasn't just an improvement, it was a fundamental shift, a whole new lasting way to understand and design data systems that, run so much of our world.
I think the core takeaway here is that the ER model gave us this crucial layer of abstraction,
Right.
a clear, structured way to think about data that wasn't tied to one specific technology.
Made it understandable, plannable.
Exactly. And that simple, powerful idea just spread and had this incredibly broad, lasting impact on, well, almost everything in IT.
And for you, listening in, if you're trying to get up to speed on tech concepts quickly and thoroughly, understanding the ER model, it's like getting a master key.
Yeah, it really unlocks a deeper understanding of so many systems you use constantly, maybe without even realizing it.
Which leads to maybe a thought to leave you with.
Yeah.
Well, as data just keeps exploding, right? Volume, complexity, it's always growing. How might these fundamental ER principles, the core ideas, need to change or, evolve?
Good question. Especially with things like AI, the Internet of Things, pushing the boundaries of information management. How does this 1970s model adapt? Or what comes next?
Definitely something to chew on. And look, if this deep dive has piqued your interest, we really encourage you to maybe dig a bit deeper, explore database design more, or even the history of software engineering.
You'll probably find the ER model popping up again and again.
Yeah.
It's just that fundamental,